Hey guys, welcome back. We're going to begin with chapter 10, section 10.2, where we're going to be discussing parabolas. Alright, so chapter 10 deals with conics. First order is a parabola, then we're going to do ellipses, hyperbolas, and then we're going to be doing some rotation of conics, and then we're going to jump into parametric and polar. Notation, equations, and graphs. So a couple of things that we're going to be learning, which is primarily going to be focused on writing equations of parabolas in standard form and also graphing them. So far we've graphed parabolas that open up or down, and we're also going to be doing parabolas that open to the right and to the left. So that's going to be something new for you guys, and let's get started. So chapter 10 is conics. So in the world of conics, we have a few things that we've already touched on. One of them being two lines that are intersecting. We have a double cone here and a plane that intersects right here where these edges are that you see, these dark lines. Well, that's intersecting two lines. Comparing that to only one line would be a plane that is tangent again to these cones, this dark red line, and that is the world of linear functions that we've also been working on since middle school, right? And then of course when we begin geometry, we always start with the point, which happens to be the intersection of these two cones. So what we're going to be doing today is, if you have these two cones and you have a plane and you go ahead and you intersect the cones, well, we're going to be intersecting just one cone, and as you can see here, this dark line, that is the shape of our quadratic function, which we call a parabola, right? So this is the parabola. This is what we're going to be working on. You can imagine there's a few more cones that we're going to be dealing with, the ellipses and the hyperbolas, which I will show you in the next videos. So here is a new definition for a parabola. So a parabola is a set of all points, x, y, in a plane that are equidistant from a fixed line and a fixed point. All right. So in order for us to draw a parabola, we need a fixed line and then we need a fixed point. And all of the points that are equidistant, all right, is going to form our parabola. So it's going to look something like this. So right here we have our fixed line, which is called the directrix, which is right here, this dotted line right here, and this is my directrix. And then we have our fixed point, which we call the focus, right there. And then this guy right here in the middle, the vertex, well, we already know how to find that, right? We already know that that's either the lowest point or the highest point. So every single point that is equidistant, right? So in other words, this distance right here and this distance right here are the same, and this distance right here that I'm highlighting is perpendicular to that directrix. All right, and that is going to form our parabola. So if you wanted to graph a parabola on paper, right? So what you're going to need is, you're just going to need a fixed point, which we're going to call a focus. Then you're going to need a line, which we call the directrix, like that. And you're going to have to find, right, using the ruler, right? You can find all the points that are going to be the same distance, right, and perpendicular to the directrix. So like right there. And then we do another one this way, boom, boom. So there's another point. And we can even go like this, boom. Just imagine that this is drawn to scale, right? So in our parabola, it's going to be looking something like that, right? So that is how this is how you would draw a parabola on a paper without having any axes, right? Without having any function, without having anything but a ruler and a pencil. So you need a focus and you need a directrix. All right. So if you want to just pause this real quick and go ahead and write down the standard forms of the equation of parabola. Now this is definitely different from what we're used to seeing, right? We're used to seeing this guy down here where we have ax squared plus bx plus c, and then we can either factor it or we can put it in standard form or vertex form, which I'm just going to label it as g, like this, right? So this is what we've been used to. Well, if you, let me raise this up real quick. So if you can get to this form right here, then you can get to this form, all right? Vertex form to that form. All you got to do is, if you notice here, is these equations right here have the squared value by themselves, right? Which is, if we look down here, it's this one right here. So in other words, just solve for that. If you have it in standard form, in vertex form, to put in the standard form of a parabola, then we go ahead and just solve for that squared part. And then one little side note that I want you to write here is the coefficient, right? So let me put that, I guess let me put it up here. The coefficient of y is 1. And that's going to happen right here, okay? So in other words, you're just going to factor whatever's in front of y from y and k. And that's how you're going to get the 4p. All right, so you're just going to factor whatever's in front of it so we can get the 4p. Now, what does a p represent? I think it's better if I show you a picture on what p represents. That way there's no confusion. All right, so go ahead and just pause this if you haven't already, and write down these formulas in your notebook. That way you can have them handy for when you're working on these homework problems. All right, so just to illustrate, this is the parabola that we're used to seeing opening up. And I want you to focus right here on this P. I said it's better if I illustrate it. Well, P is going to be the distance from the vertex to the focus. All right? From the vertex to the focus. That is what P is going to represent. And which we can get it if we put the quadratic function in its standard form that we just saw. All right. How do you know if it opens up or down? It's by the leading coefficient, which in this case we're going to be using the 4p. If p is positive, then it's going to open up, and then if p is negative, right, then it's going to open down. And then we also have parabolas that open to the right and to the left. We really haven't dealt with those, and the only thing that's different is instead of having x squared, now we have y squared. All right, we kind of did see them when we were doing the inverse of a quadratic function, but then we had to restrict it, and we had the square root function. But now if you have a square root function and you square both sides, then you no longer have a square root function. You actually just have a parabola that is lying on its side, which means it's going to open to the right or to the left. If you want to think of it opening to the right, it'll be like opening up. So it's going to be, the P is going to be positive if it's going to open to the right. And then if the P is negative, it is going to open to the left. So think of it as opening down. And then I just want you to focus real quick on these expressions down here, right here, okay? Notice how these have the y is to the second power, and the ones on the left have the x to the second power, which is the ones we're used to. All right. So again, we can have parabolas opening to the left, to the right, up or down. It's just going to depend on where the square is on the equation that you're working on. If the square is with the y, then you're on the x-axis. Now, if the square is on the x, then you're dealing with the y-axis. It's going to open up or down or left or right. All right. So if you want to go ahead and just pause it so you can write this information down. All right. So let's look at our first example, which is the following equation.